other portions. We'll start with the combination of the pulley, and then we'll try to finish off this chapter as soon as possible. Now, one thing I would like to know that since we have done only 3 chapters, okay, will it be feasible for you to, if I send you the notes for the other chapters also, maybe 1 or 2 chapters through WhatsApp? Maybe we are not able to connect to the School Mitra or the Zoom, or we might try to take the class on the Google Class. Only if you agree, then I may go for that Google Class another during your vacation. Had studied about the pulley system, and we studied about the 2 types of pulleys, that is your single fixed pulley and your single movable pulley. Okay, so the basic structure of the pulleys, how they are working, and what is the effect of the effort and the load, okay, how we are using those pulleys, that has been given through that single movable pulleys and the single fixed pulley. Now, the other arrangements, what we are going to do is we say it as a combination of pulleys. So we are already aware of what is a single fixed pulley and what is movable pulley. So now what we can do is we can arrange them in the different formations and then try to see how these pulleys work. Okay. So for this, what we do is we have 2 different system of arrangement. In one system, we have one fixed pulley, and there are several movable pulleys which are being attached to each other, okay, with the same rigid support. This type of arrangement is called as your Archimedean system. We have another system where we have the several pulleys being fixed together, okay, in the form of different blocks, and these blocks are being used using a ring or a rope, and we use it as a block and tackle system. So basically we are going to study about these 2 basic arrangement or the combination of the pulleys, that is your Archimedean system and your block and tackle system. Now, in case of we start with Archimedean system. So in combination of pulleys, we have 2 systems. One is your Archimedean system, and the other is your block and tackle system. So the first thing what we are going to do is we are going to study about the Archimedean system. Okay, you can refer to your diagrams in the book. Here also I will draw the diagram, but you know the standard of the diagram is not very good. So we start with the Archimedean system. Archimedean system basically is a system, if we say it as A. In case of Archimedean system, what we have one fixed pulley, and we have several movable pulleys. Now which have been attached to a same rigid support. I'll try to draw this a little bit so that you get an idea about this. So here what we have one pulley, okay, which now this is a movable pulley. This is another pulley. Required to draw it a bit down. So I'm rubbing it. It's not like that. This is a wrong one. This is a third pulley. And then we have one fixed pulley. I'm not doing exactly. Should be a bit more close. Alright. So this is pulley A, pulley B, pulley C, and pulley D. Okay. Out of which A, B, C and A, B, C are your movable pulleys and D is your fixed pulley. Okay. Now if we try to apply the load and as a result, now this is the load which is being attached to the fixed pulley. Let it be L. Okay. Now here the load is attached. We will apply the effort at this arm. So when we are trying to pull it down, okay, by applying an effort E, so as a result of this effort, there will be a tension created, okay, in the string. That is your DE if we consider for the time being. Now, this load is going to create a tension in the two arms of the string. This will be your T1 and this will be your T2. Okay. So because both the tensions are going to be equal and your L will be equal to T1 plus T2. Clear? Similarly, now T1 will be acting as a load for the pulley B and this will be creating a tension in the two arms of pulley. This will be your T2 and T. Similarly, T2 will be acting as the load and its effect will be experienced in these two arms, T3, T3. Now when you apply this effort, T3 here and this T3 will be same. Alright? So here we find that the effort applied is equal to T3 and then we'll have to calculate the load. One thing you should note down while drawing that the string of the previous pulley should be connected to the axle of the or the hook of the axle of the next pulley in each of these cases, and this is going to be passing through the other pulley. So they should be more closer. It's not like they are going to be away from each other. Clear? So this is a diagrammatic representation. I will use it to derive the mechanical advantage and we will see how this pulley can be utilized. Okay, so I'm rubbing the diagram. Uh, you can refer for the diagram, you can refer to your book. Okay, it's given on page number 62, the old book. New book, it might be a 61 or 63, or it may be in 62 also. Now, let us calculate. When we apply, so we are trying to calculate the mechanical advantage. Now, if we are trying to calculate the mechanical advantage, so if we are calculating the mechanical advantage in this case, we are trying to calculate the mechanical advantage. So in equilibrium, I have told what does it mean? When we are lifting the body and the body is leaving the ground. So the effort will be equal to T3. That we are always aware of. Okay, because in the last fixed pulley, when we are trying to apply the effort is in downward direction and T3 was acting in upward direction. So effort is equal to T. Now we move from pulley A. In pulley A. So if I draw the pulley A, here we had the load and here, so this load L, and on both the arms we have T1 and T1. So load L will be equal to T1 and T1. We have already seen this, that in case of a movable pulley, the load is equal to twice the tension. So this we can write it as L is equal to 2T1, or T1 we can write down as L by 2. So the tension in each string will be half of that of the load. Okay. Similarly, for pulley B, what we were having, here we had tension T1 and here we have tension T2. Okay. Now this tension is going to be balancing. So here T1 will be equal to T2 plus T2. That is T1 will be equal to twice of T2, or T2 will be equal to T1 by 2. Okay. Now T1 by 2 we can also write it as T1 is equal to L by 2. Okay. So this becomes L upon 2 into 2, or we can also write it as L upon 2 to the power 2. Okay. Then for pulley C, if you observe, T2 was this one and T3 on the two arms. Okay. So here what we have T2 was equal to T3 plus T3, or we can write down T3 is equal to T2 by 2. And here we have already seen T2 is equal to L by 2 to the power 2. So L by 2 to the power 2 into 2. This will be equal to L by 2 to the power 3. So what we have finally is okay, we have T3 is equal to L upon 2 to the power 3, or we can say that L is equal to 2 to the power 3 into T3. So now mechanical advantage, if we try to calculate, if we are trying to calculate, that will be your load by effort. So load is given as 2 to the power 3 into T3 upon effort is T3. It comes out to be 2 to the power 3. Here, it's important to understand what does this 2 to the power 3 mean. If you try to observe the number of movable pulleys which we were using in this system, okay, so 3 basically represents number of movable pulleys. Okay, so now instead of 3 movable pulleys, if I have n number of movable pulleys, okay, so the number of movable pulleys, let it be n. So mechanical advantage is equal to 2 to the power n. So in case of one fixed and several movable pulley, the mechanical advantage is equal to 2 to the power n, where n represents the total number of the movable pulleys. I hope this is clear to all of you. The basic concept is same. Movable pulleys, we have already studied. Okay, in case of the movable pulley, the load is going to be balanced by the two tension, or the load is divided into two tension. Okay, so is there any question up till here? If you have any question, you can ask through the chat. Very less attendance. Physics nobody wants to study. Everybody wants to become that is what I was explaining you, Mayank. Okay, it is not possible to show the derivation, but okay, I will try. Say if L is equal to T, then is equal to T by 8 if there are two movable pulley and 1 2 to the power uh, yes, you can have 1/8. Yes, definitely. But if you are having two movable pulleys, then it will be Devesh Pandey, that how this is going to be related to the number of pulleys. Okay, so if you write down 4, or you write down 8, or you write down uh, 10, okay, so that is how we have to understand. So now we move to the velocity ratio. So remember that now for velocity ratio, okay, now in case of this Archimedean system, if you try to observe, another way you can say, if we don't write down in terms of the fraction, you can do it in both the ways. Okay, so we can say that the effort is moving twice the distance of the Archimedean system. Okay, that is one fixed and several moving. Okay, so in that case, what happens? The load, let the load move by the distance x. The pulley in. All right. The other side, which has been attached to the axle of the pulley B. So that string is going to be moving twice the distance moved by the load. Okay. So for pulley B, you can say that string connected to B moves by distance 2 into x, that is 2x. Similarly, for pulley C, if you observe, the pulley C is going to be moving. For pulley C, the string attached to pulley C will be moving through the distance twice that of pulley B, and this will be equal to uh, into x. All right, you can say it as 2 to the power 2 into x. Clear? And similarly, now you are applying the effort on the pulley D, the string, the other end of the string of the pulley D, and this is also going to be moving by pi. So for D, the distance moved, and this we can consider it the distance moved by the effort. This will be twice the distance moved by the string in pulley. So 2 to the power 2x. This we can write it as 2 to the power 3x. Okay. So now the distance moved by the effort is 2 to the power 3x. Distance moved by the load is x, and therefore if we calculate, so dl comes out to be x, dE comes out to be 2 to the power 3x, and therefore velocity ratio, which is equal to dE by dl, this will be equal to 2 to the power 3x by x. This will be equal to 2 to the power 3. Okay. Similarly, again if we refer to this 3, this is basically representing the number of movable pulleys. So if I have the number of movable pulleys as n, therefore the velocity ratio can be written as 2 to the power n. So if you have 3 pulleys, it will be 8. If you have 2 pulleys, it will be 4. If you are having 5 pulleys, then 2 to the power 5. That comes out to be round about 32. Okay. Then comes the efficiency. Efficiency, again, for the ideal case, this will be your mechanical advantage by velocity ratio. This will be again 2 to the power n upon 2 to the power n, and hence we get the efficiency as 100% or as 1. Clear? But again, this is going to be an ideal case. This efficiency is an ideal case. Ideal case means there is no friction at the axle, the strings are massless, and even the weight of the pulley is also negligible. Okay, so this is about your Archimedean system. Now, overall, if you try to observe for the Archimedean system, okay, we find that the mechanical advantage in the Archimedean system is 2 to the power n, velocity ratio is 2 to the power n, efficiency is equal to 1 for ideal case, and since mechanical advantage is greater than 1, okay, we find that this is going to act as a force multiplier.
कि हाँ तो अमरदीप ने मेरे व्हाट्सअप किया तो फिर व्हाट्सअप पे मैंने जब मेरे को पता लगा तो फिर मैंने जो वेबसाइट खोले उसका है वो
Okay,
तो हम लोग ने
now
और
it's
आप बैठे कल कोचिंग
acting
में
as a force
तो
multiplier. Why we are using or why we are
यहाँ पर
studying?
है
We have already
सब्सिट्यूशन
seen
तो
that
मैंने
in
कहा कि
case
सर
of
ऐसे
your
कैसे लगा
single movable pulley, the mechanical advantage happened to be 1. Okay,
नहीं तो ऐसे
so
कैसे लगा
happened to be 2.
क्या
Uh, but in case of our median system,
हाँ
it is increasing in exponential form. And since it is increasing in exponential form, so with a very less amount of effort, we will be able to lift a much greater load. Okay, so say for example, uh, if I have a load of 1 kg, or sorry, if I am applying an effort of 1 Newton or 1 kgf, and I am having, so if I apply an effort of say 1 kgf, and the mechanical advantage, if I'm using this 3 system, mechanical advantage happens to be 2 to the power 3, that is
भाई जहाँ
8.
मैं बैठा हूँ वहीं पे बंदा है सावधान रहना
So
उसके पास
what
कोई
I am
हथियार
able
नहीं
to
है
do is I'm able to lift the
ऐसे नहीं
load
करना भाई थोड़ा आगे
8
चल जाओ
times.
भाई थोड़ा आगे चल जाओ
तो उसमें क्या
भाई जहाँ पे हमारा
This will be
अगर
your
3 नंबर है तो
mechanical advantage.
3 नंबर
Mechanical advantage into effort. So if you try to observe,
हेलो जी
I am able to lift 8 times of that
हेलो
load. That
हेलो
means
भाई
with an
प्लीज़ भाई
effort
मेरी
of
जगह
1
पे चल जाओ भाई
kg, I am
प्लीज़
able to
उसमें
3
lift
नंबर
वो
प्लीज़
सैलरी उसमें
तेरा मेरी जगह पे चल
8
जाओ यार
kgs,
प्लीज़ रिक्वेस्ट है यार
kgf of load. Okay,
जहाँ
so
मरा
this
वहाँ
is
पे
the
चल जाओ
purpose
यहाँ पे कोई नहीं
of
है जो
using
भाई भाई
the
देखो बंदा आ गया
Archimedean
भाई
system.
भाई भाई
Similarly, if you are using, say, uh, four
भाई
pulleys,
मर गया
okay,
भाई भाई जरा मेरी
then
जगह
you
पे
will
चल
be
जाओ
able
प्लीज़
to
यार
lift
रिक्वेस्ट है भाई 3
60
नंबर भाई रिक्वेस्ट है मैं
times
जहाँ मरा वहाँ
more
चल जाओ यार
than your effort if you are applying an effort of 1 kga.
भाई वो पैड जो है मेरा चला
Clear?
दो तेरा वो जो जहाँ मैं
So I
मरा हूँ
hope
भाई
this
प्लीज़
is
वहाँ
clear
चल
to
जाओ
all of you.
ऐसे जान दो
हाँ निकला भी बेचारे कल से काउंसलिंग शुरू की है। हाँ
Devesh, it can be 4x also n. Question is not very clear.
अरे कल से काउंसलिंग
Yes,
भी शुरू
the
की कल
velocity
उसमें
ratio
ज्वाइनिंग
will
हुई।
always remain constant. We have already studied. Basically, if you try to change the velocity ratio, okay, so the
एक
law of
बार पूछा भी
conservation
तो
of
कल वहाँ
energy
पे
is
जिससे
basically
मैं
not
आज उससे
followed,
पहले टीचर को
and
पढ़ लिया था यार
therefore we
उससे
find
सही है।
that velocity ratio will never change. The adjustment is done in terms of the mechanical advantage and in terms of the efficiency. So mechanical advantage decreases, the efficiency decreases, the mechanical advantage generally it doesn't increase. Okay, so the efficiency is also not going to be increased, and therefore we find that the efficiency is less than 1 for 100%. So I hope it is clear to all of you. So now I'm moving to the
वही हम देखे तो कल जब हमें पता लगा था हम लोग
power
हमारे
2x in
सर यार
place of,
नहीं नहीं आपके लिए
and we
होगा।
write down 4. Yes, you can write down 4. For actual values, you can write down
हेलो
4.
भाई
But in order to
भाई
express it or
यहाँ चल
relate
जाओ
it
देखो
to the
जब
number
मैंने
of
यहाँ चल
pulleys,
जाओ
it
इंडियन
becomes
रेलवे की
more
वेबसाइट
easier
पे
to
जाके
understand. And that is why we are relating
वो
that entire
वो
value,
जो है ना वो
हाँ
नंबर
भाई
okay,
चलती रहती है किसी में
with
पढ़नी
that of
रहती है सही
number of
लिखनी
pulleys.
रहती
So if you are able to write down final answer, you write down as 4, no problem. Mechanical advantage 2 to the power
है।
2,
हाँ एक बार एडवर्टाइज
okay,
देखी
that
थी
comes out
वेबसाइट
to be 4. Okay, but if it is somebody is asking how many, if the mechanical advantage is 4, how many pulleys you are using, then definitely you should be able to know that, okay, 2 pulleys we are using over there. Okay.
हाँ प्लीज भी दिया डॉक्यूमेंट भी दिया था हाँ
The Archimedean system, generally the change in the uh, mechanical advantage is not
यही
taking,
बात है
sorry, the change in the direction is taking place with the help of the fixed pulley, and therefore we are not able to see, uh, and generally in case when we are having a
वो
combination
प्रोसेस उधर
of
निकाल लेंगे
the fixed pulley. So fixed pulleys, we have already studied that it is
हम लोग जो
basically
होंगे
used
वो
to change the direction of the effort applied in the convenient direction. Okay, and therefore what you find is
हाँ क्योंकि इनपुट में
that
निकाल देना चाहिए
the
क्योंकि
mechanical advantage is not going to be one, because for that it is only one, and
अरे हम
for the
यहाँ
other
थोड़े
pulleys
ऐसे
we have
कोई
to
कागज
find
वगैरह
out for
होता
the
है कि
movable pulley. I have
हाँ
also
हाँ
shown you that or explained you that when we are using the fixed pulley, basically we are using it for
शिक्षक का छात्रों
changing
का
the
ज्ञान
direction
बढ़ती है
only, because we have already
हाँ गुरु
calculated
जी
the
का
mechanical
ज्ञान
advantage
बढ़ेगा
of the fixed pulley, and we have seen that it is equal to 1. Okay, and therefore it is used to
अरे
change the
शिक्षकों और
direction.
छात्रों का
I
ज्ञान
hope you
सुधर
got
जाता
the
है ना
meaning.
हाँ सही बात है भाई तीसरी की मीटिंग हुई कक्षा शुरू किया मैं
Okay,
ये रजिस्ट्रार सर ने
so we
कहा
move
फोन
to the
आया था
next
उनका
system,
उनका
that
आगे
is
क्या
block
आगे
and
हार्ड
tackle
स्टार्ट
system.
हार्ड स्टार्ट
Please practice the diagrams. Okay, it's important to practice the
नहीं पहले था
diagrams.
अरे वो क्या नाम है अरे नगर निगम में पुलिस वालों में निकल गया था
So now we move to the
पहले
block
ये
and tackle
50 मीटर
system.
जहाँ पहले रहते थे बगल
Okay,
में हाँ वहाँ उसी मकान के सामने एक दरोगा जी का हो गया हाँ तो इसलिए जो है इधर महबूबगंज में सूर्या कॉम्प्लेक्स में हुआ था हाँ हाँ तो इसलिए जो चाहो तो हॉटस्पॉट हम करवा दें क्या ठीक है आप वेबएक्स के थ्रू जो है ऑनलाइन
so
जो
we
है
have block block and tackle system. In this is also
धन्यवाद। तो
a
आपको थोड़ा
uh,
सा हालचाल भी ले लें और जो है
combination
और
of
आगे
the different type of
सब
police.
ठीक है।
Okay, we
ठीक
have
है, बता रहा हूँ वो
one part called as block. Block is basically a framework where two or more number of pulleys are been attached to the frame. Okay, so any number of pulleys. So say for example, if I am having a block, I will be having a different number of pulleys being attached to it. Okay, so this will be called as the block. Or I may have. So this entire arrangement is called as your block. Now there are two systems of movement in this case. Two. So okay, one is called as the upper block. Now this is your block. Okay, there is set. Out of this, what you can do is one you can keep it as an upper block and one you can make it as a lower block. The upper block is called as so we have two portions in case of two types of block you can say. Okay, we have upper block or we call it as the fixed block. Definitely this block is going to be fixed. The axis of movement is of the pulley is going to be fixed to a rigid support if the frame is so the and the lower block is called as your or the other block is called as your lower block. This is a movable block. Okay, upper block is fixed. Number of pulleys, that is n, if I consider, okay, the number of pulley is either greater than or equal to the number of pulleys in the lower block, and similarly the number of pulleys in the lower block is going to be less than or equal to. So if I represent the upper block as nu and lower block as nl, then the number of pulleys in the upper block is going to be either greater than the number of blocks in the lower block, okay, or it will be equal. The lower block will never have the number of pulleys greater than the number of pulleys in the upper block. Okay, maximum it can have is equal. Both of them can have equal. Okay. Also, the weight of the pulleys in the lower block should be as light as possible. Okay, this we will study towards the end because the weight of the pulley also affects the mechanical advantage and the efficiency of the block and tackle system. Now let us see how this block and tackle. This was block. Now what is a tackle? Tackle is basically the string or the rope which is binding both of them. String or rope which passes through the pulley set, okay, the two blocks to bind them together or to, okay, this is called as your tackle system. So now if I try to draw the block and tackle system,
भारत है और किसी को कमेटी बनाई गई है सबके साथ क्वेश्चंस पूछेंगे सही है कि गलत है क्या है अगर उनकी बात सही है तो भाई वो फिर निर्णय लेगा ऐसे करते करते आगे चलता है बताइए शिक्षा में कोई खुशी आ गई
I'll take a
कॉलेज भी
bit
तो आप लोग
longer.
क्या
also keep in mind the size of the pulleys will be slightly decreasing in nature so that the tackle can pass through them easily. If they all are of same type, the tackle might be entangling in between. Now circles are not done properly, but you try to understand. So here we have one hook and here we have another hook. One hook here through which we are going to connect the load, and this is going to be attached to a fixed. Okay, so two blocks. This is your upper block, this is your lower block. Now in this case, if we try to pass that rope or string or the tackle as we say it, this is basically for n equal to 5. The total number of pulleys in the both the blocks together. Okay, that is upper is 3 and lower we have got 2 and total is your 5. So now if you try to pass the tackle I will take some other. So since it has got a upper block more number of pulleys, lower block less number of pulleys, so the string is going to pass from the hook of the lower block, moves to the upper block, upper, then lower, then upper, then lower, then upper. Now you can start from the lower also, you can say, but the thing is that the direction of the effort should be in convenient direction, and we all know that the downward direction is more convenient. So now if we mark the direction first for the effort is down, and this load is down. Okay, so load is going to act downward and effort is also going to act downward. But now if you try to observe, the upper block is being attached to the fixed or the rigid support. Therefore, the entire is being taken by the entire weight of the pulleys is going to be taken or will be experienced by the hook. But the lower block, if you observe, the weight is going to be experienced by the tackle, that is the string. So now if I consider this, okay, so here in this case the load is acting downward. For the timing I consider that the total weight of the lower block is negligible, there is no weight. So main weight is of your load, so this is going to be acting in upward direction. Okay, this is your tension. Similarly here also this is going to act in upward direction, tension, and this is also going to act upward direction. Okay, so here we can make out that load is going to be balanced by all these tensions. Okay, so here we have 1 2 1 2 3 4 and 5, so we can write it as 5P. Okay, this effort when we are pulling the string down, so there will be a tension which will be acting in upward direction, and as a result effort will be equal to T. Now if we calculate the mechanical advantage, this will be your 5T upon T is equal to 5. So mechanical advantage becomes 5. So if you are applying an effort of 1 Newton, okay, then you can lift the load of 5 newtons. Okay, so this was about your mechanical advantage. Similarly, this is for n equal to 5. Okay, so remember this. this case also, if you try to observe, if I observe that the distance moved by the load in upward direction happens to be x or happens to be t is equal to d, the load has to move, or sorry, the effort has to move 5 times of this. Okay, so the distance moved by the effort is equal to 5. Clear? Because effort is always going to be moving a greater distance to compensate that magnitude of effort. Okay, then only we will have this. Okay, so here we are having 5 times, so velocity ratio will be equal to 5t upon d, it is equal to 5. Okay, so this is about for n equal to 5. Now if I take n equal to 4, for n equal to 4, both two, three, 4. So here we are having 4, so both of them can have 2 each, that is equal to the upper block here also you will have, so load, this has been attached to a fixed hook, and in this case the tackle will pass from starting from the upper, passing to the lower, upper, lower, then upper, and then lower. You can start from left side, you can start having the convenience. Okay, so now load is going to head down, effort when we are applying, T, and these tensions will be same of the string, that will be in upward direction. So T
ठीक
and
है.
T. So and the effort will also be balanced by the tension. So here we have effort is equal to E and the load is equal to 1, 2, 3, 4. 4T. So mechanical advantage is equal to 4T by T equal to 4. Similarly, the distance moved by the load, let it be D, so distance moved by the effort is equal to 4 times of it. Okay, and as a result we find that velocity ratio is equal to 4. Now n was equal to 5, mechanical advantage 5, velocity ratio 5. N equal to 4, mechanical advantage 4, velocity ratio 4. So if we take the number of pulleys as n, okay, so mechanical advantage will be equal to n, velocity ratio will be equal to 4. So which means that in case of lock and tackle system, lock and tackle system, Mechanical advantage is equal to n, velocity ratio is equal to n. Okay, efficiency definitely will be equal to 1 m for the ideal case. Okay,
ये मेरी बात नहीं बताया है।
where n represents number of pulleys. I'll say number means total number. It's not like it is not like only in the upper or in the lower one. Okay, so I hope it is clear to all of you. Is any question? Yes. Okay. Now we are left with a very small portion. Okay, but the time is also going to be over, so I am not going to start with it. The last portion basically where it tells you that the weight of the lower block should be negligible. So we can go through, you can go through it and then see how you will be able to see that if the how the uh, weight of the lower block is affecting the block and tackle efficiency of the block and tackle system. Okay, so we have nearly finished off the second. Next class we will be dealing with some of the numericals related to block and tackle system. Okay, some exercises and your questions. If you have any question, if anything is not clear, so I'll be explaining this and then moving to the block and tackles, to the numerical part. Okay, and you can explain me through the group, or you can inform me through the group. I still want to, if I am able to complete as well and good, but if I'm not able to complete, then I will try to send the notes through the WhatsApp. Okay, so be connected. Is there anything you want to ask? I just